Whisker Plots, you guys are going to go ahead and flip to the back of your vocab section. So this is be at the back of your notebook. And we're going to be defining a few things that are going to come up when we're talking about box and whisker plots today. So the one will be number 6 in your vocab section, and we're going to write box and whisker plot because we want to define what we're talking about today. So a box and whisker plot is a graph that displays the highest and lowest. So the highest and lowest quarters of data as whiskers. So the lowest and the highest as whiskers. And the middle 2 quarters as a box. The middle 2 quarters of data as a box. That's a little better. The box is divided by the median of the data. So we're going to put a semicolon here. The box is divided by the median of the data. So that's an explanation or a formal definition of what a box and whisker plot are. Let's also talk about a couple more things. We're going to talk about the first and third quartile and an interquartile range, which are kind of fancy sounding words, but once we break it down, it should be pretty easy. So number 7 is the first quartile. Now I see that quartile has the word quart in it, so it's probably 1/4 of something, right? So for a data set with median in, so if we have a data set and the middle number is m, the first quartile is the median of data less than m. First quartile is the median is in the median of the data value is greater than n. Okay, so for example, if we have a data set 1, 3, 6, 7, 10, 12, 14, 15, 22, and 120, then the median is, let's see, 1, 2, 3, 4, 5, so the median is 11, right? And then the middle of the data to the lower side would be 1, 2, so this right there. So the first quartile is 6. It's the median of the data that is less than the median of the original set. So if we take that into consideration and we do 8 as the third quartile, the third quartile should be the same thing, except for it would be the ones that are greater than the median, right? So for a data set with median M, the third quartile is the median of the values. Yep, I messed that up. So we're going to switch this to less, right? Quartile is in the median of the data values greater than this time, greater than M. So if we had the same data set, 1, 3, 6, 7, 10, 12, 14, 15, 22, and 120, where the median we now know is 11, it's the average of these two middle numbers. And we knew the first quartile was 6, then we have to go on the other side where the numbers are bigger, and we'd find the third quartile to be 15. And we'll talk a little bit more about quartiles in a second. The last one for number 9 is something we're going to be talking about called interquartile range. So I'm guessing that you could probably figure that this would be the range of the quartiles, I'm going to guess, right? Interquartile range. Okay, an interquartile range is a measure of variations in a set of numerical data. So it is a measure of variation in a set of numerical data Okay, the interquartile range is the distance between the first and the third quartiles. So, the interquartile range is the distance, let's write difference, because that's what we want. The difference between the first and third quartiles. So given the same data set that we were talking about, with this data set here that we use, we have the first quartile, which was 6, and the third quartile, which was 15. So the interquartile range is the third minus the first, which is equal to 9. So the interquartile range is the distance between the first and third quartile, which now is 9. So this would be interquartile range for the data set that we see here in the examples. Okay, so that's all the vocab we have for this one. We're just going to do those 4 vocabulary terms. So if you're ready to go on, you're going to go ahead and flip with me. If you are not ready to go on, then you can pause the video and you can do some more work on this one. Okay, today we are going to be working on item number 15, so please be sure that you found 15 in your notes section. And we are going to write box and whisker plots. Box and whisker plots. Okay, and so at the end of this, you will be able to create a box and whisker plots from data and label the upper quartile, lower quartile, the median, and properly place the box and whiskers. So we're going to be writing an objective that says students will be able to create a box and whisker plot from numeric, which means number, right? Numeric data. So you will know that you have learned what we're supposed to learn if at the end of this lesson you are able to create a box and whisker plot from numeric data. Okay, so let's look at what a box and whisker plot is. Okay, box and whisker plot, put a little star, is an easy way to graph data on a number line using a 5-number summary. So it's an easy way to graph data on a number line using a 5-number summary. And of course you're probably already thinking, okay, what 5 numbers is she talking about? Well, let's first look at a generic number line. So here's a number line. It's got a lot of these little hashtags. We're going to pretend, hashes, not tags. We're going to pretend like they're nice and evenly spaced. So let's look at what we're talking about. So when you see a box and whisker plot, you're going to see a box like this. Okay? And this guy right here, the bottom end is going to be your lower quartile, or probably we'd call that your first quartile, like we just defined it, right? First or lower. So what do you think this one's going to be? You're right, that's going to be the upper or the third quartile. So this is upper quartile. We might have called that the third quartile. You're going to find some kind of cut in the middle. It's not probably going to be exactly in the middle, but it might be. This is called the median. Okay. Then you are going to have these little whiskers on the end. And so these are here are called the box. And this guy here is a whisker. And this guy over here, he is a whisker. And in these whiskers we have the greatest value over here. And we have, guess what, the lowest value over here. And remember how I said we're not real sure where those 5 numbers come, the 5-number summary? Well, let's look. 1, 2, 3, 4, 5. Oh, look, those are our 5-number summaries. So the lowest value, the highest value, the median, and the first quartile and the third quartile, those are the 5 numbers that we're going to need to draw a box and whisker plot. Okay, so let's talk about each of these things. So we'll talk about the median first. So let's use some information to find some stuff, and we'll draw a box and whisker plot. So the median is the middle number, right? We already knew that. That's pretty easy to find. Okay, so in this data set, we put them in order. 1, 3, 6, 11, 15, 19, 23, 24, 35, 46, and 56. And then we find the middle one. 1, 2, 3, 4. Should be 1, 2, 3, 4. There it goes. Make sure that's even. So this is an odd number, so that would be perfectly in the middle. So this will be the middle or median of this data set. This is when we have, these were an odd number of data, right? Odd number. But what if we have an even number? Then we're going to need to use something a little bit different. So here's what we do with an even. If we have 3, 6, 11, 15, 19, 23, 24, and 35, we would find that this is an even number. So 1, 2, 3. Oh no, we have 2 middle numbers. So we would take these 2 and we would average them, use the mean average to average them. So that would be 15 plus 19 divided by the 2 numbers that we have, giving us 17. So the median of this even numbers of data is 17. Okay, so that gives us, that's pretty easy. That's how we would come up with the median for that data. Okay, so next we're going to have to look at a box and whisker plot. So let's go ahead and use this set of data here that we just talked about, and we're going to go ahead and draw that box and whisker plot. So let's put a nice number line here, and it looks like we're going to start with, say, 3, let's do 3, 6, 9, 12, 15, 18, 24, oops, 21, 24, 27, 30, 33, and 36. That should get everybody in there, right? Okay. So there's our number line, okay? And we would have all these, so let's do a box and whisker plot. So we know the median is going to be at 17. So we would have our line, and we're going to do this underneath somewhere about 17. Let's go say it's, well, right about there, okay? Then we're going to look at the stuff on the left side to find the next section of the box, and we're going to find the median of the left side of the data. So looking at 17 over here, we would go we're going to have to find the median here, which is 16 plus 6, which is 17 divided by 2. Off the top of my head, that's going to be 8.5. So somewhere right in, real close to 9 would be the lower quartile. Okay, and so that would be 8.5 for the lower quartile. And then we're going to average 23 and 24 to get 23.5. So pretty close to 24 here. And that's going to give us the lower quartile, or upper quartile, okay. Then we have 3, so this was going to be 23.5. Our lowest point is 3, so that'll be where our whisker ends. Our highest point is 35. Oops, 35. So that is where our guy is going to end on that side. So that is how we draw a box and whisker plot. Okay, we use those 5 numbers to draw a box and whisker plot. Okay, so that's how we draw it. Now we can go about looking at some more information and some more data so that you can are able to draw another box and whisker plot. So I'm going to turn the page. If you need more time, go ahead and pause. Otherwise, just keep going. Okay, so let's look at some data. Let's see. We have 34, 49, 29, 24, 94, 36, 90, and another 36. These are just some random, let's say, I don't know, test scores or something, right? So let's draw a box and whisker plot. So let's see, we know that we're going to first need to put them in order. So we had 24, and then 29 it looks like, and then 34. I have 2 36s. Make sure you write both of them down. We don't want to leave out any numbers at all. Then we have a 49 and a 90 and a 94. If we leave out any numbers, it's going to skew our data, so we're going to want to make sure that we do that, okay? So now we're going to find the median. So we put them in order, and now we're finding the median, right? Because that's our first number. So we're going to 1, 2, 3, and we have an even number, so we're going to have to average 36 and 36. Well, guess what? When you average 36 and 36, you're going to get 36. That's right. So our median is going to be 36. Okay, so then we're going to look at the ones to the left, and we're going to go 1. Okay, well, these ones need to be averaged to find the median of this data. So 29 plus 34 is equal to 63 divided by 2 is equal to 31.5. So this is where the first quartile is going to be. And then we're going to average these two here because they're the middle points in the third quartile. 49 plus 90 is 139 divided by 2 is 69.5. So those are the upper quartile. Okay, and then our highest point is 94 and our lowest point is 24. Okay, so we can now draw our number line, and let's go 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Ooh, and then we'll just put 95 because I can't squeeze any more in. Okay, normally you probably should have done that a little bit more carefully. All right, so we're going to put our median at 36, which is about here. We're going to put 31.5 here. We're going to put 94, oops, not 94, 69.5, 69.5 would be about here. It's going to have a crazy box. 94 will be our other whisker point, and 24 will be our other whisker point. So that's what the box and whisker plot would look like here. As you can see, there's obviously an outlier or two. So if I was doing this data, I might throw out the 90 and 93 because those outliers certainly made our upper quartile way bigger than our lower quartile, right? All right, so now that we know how to do a box and whisker plot, let's go ahead and interpret some data of a box and whisker plot. So let's look at this one that I have here. Okay, so you want to draw this one into your notes as well. This is a daily high temperature. So we're going to look and see what kind of, where we think that we might find the median here. Well, that median, it looks like it's, let's see, this is 80 and this is 70. So these look like increments of 5. So I'd say that's about, it's increments of 2. So I'm going to go with about 72 degrees. So that one would be B, right? So that'd be about 72 degrees. I can figure that out. Well, let's look at the other things. So it looks like our lowest point is going to be at 60 degrees. Our highest point is at about 92. That means our first quartile range would be about, looks like 68. And our upper quartile range would be, or not range, our upper quartile number would be about 86. So if we went from 68 to 86, what would our inner quartile range be? So we would go from 58 minus 86, and we're going to take the absolute value since I did it backward, and we'd have 28. So the inner quartile range there is going to be 28, right? Okay, so let's look at, I think that about sums it up. So if you're just going to have to pull out things like the lower quartile or first quartile and the upper quartile, and this is the median, and this is going to be the low point, and this is going to be the high point. We're going to use those 5 pieces of data to graph our box and whisker plot. Okay, so I will have some homework for you. I think that I will have a copy of the homework ready for you. So go ahead and look to me for what our homework is going to be. I think I'm going to try and find something better than the workbook. So